Hello, everyone. Welcome. Thank you for coming. Thank you for choosing this session. Welcome to Transformative Git Practices, new techniques for hyperproductivity. As you might or might not tell, I put a lot of effort into crafting titles that, grab your attention. And now it will be on me to prove that the title matches the content. So hope I'll make it. You'll tell me at the end. So my name is Nicola Paolucci. I am a developer advocate at Atlassian. For the past 3.5 years, one of the topics that I've been going really deep and studying, talk about, and write about has been Git. And I don't know how much you guys have been following the development of Git and the development of the processes that go around Git in recent years. The point of this talk is that a lot is constantly happening. So there's a new Git release every few months. And the refinements are constant, and every new release, there's a couple of new commands, a couple of new flags that improve our life. The point is that if you don't follow this evolution every few months, reading the release notes and trying things out, you might miss something that is really powerful, and maybe can even make you change the way you do your daily work using Git. And so the point of this talk is twofold. Talking a little bit about how the process, software development, collaboration around Git has changed because of some of these, as we get more used and familiar with the processes and what is possible with Git. And also new commands that pop up in more recent releases. Maybe you guys haven't seen them yet, and I want to show you how they work. And maybe you'll decide to adopt them yourself. That's the preface to this talk. Now, before I start, I want to start with something funny, and that is, I don't know how many of you guys have seen already this. It was a tweet I saw a while ago, made me laugh a lot, and it said, like, if you had to describe a Git command that does this, do you know which one it is? Yes? Okay, very good. Many of you already know it. And so the point of why I'm showing you this is that because some of the things I'm going to show you today, I really think if you are in that condition, in that situation that I'll describe, you might think, oh my God, this is really useful. I want to use it from now on. So hopefully some of the things I show you will have this strong impact on your daily workflow. I make no promises, but this is why I'm here. So today we'll cover three things, actually four. And we start with one, which is worktree. It's a recent command that I don't know how many of you know about. And what this command allows you to do is to manage and create local clones in your working directory so that you can work on multiple branches at the same time in an easier way. So it's very easy to say, not too complicated to use, and we'll do also a live experiment, live demo together. So I'll show you exactly how that works. The second thing I want to tell you about today is something that's been there for a while, but I think not many people are familiar with that process. And I'm talking about interactive rebase, and I'm talking about a specific feature of interactive rebase, which is the autosquash. And when you turn on autosquash, a few cool things happen, like you gain superpowers. As you create your commits, as you're working on branches, you can start annotating and categorizing your commits as you work through them. It seems a little bit vague now that I tell you like a brief introduction. It will become clearer as we go through the examples in a bit. Third, it's one possible answer to the question, how do I do project dependencies with Git? And the Git toolkit itself, the contributions, the various commands have evolved, and we gained submodules first. And then there's a new one, there's a relatively more recent one called subtrees that not many people use. I want to go do a deep dive on how Git subtree works, and maybe you'll decide yourself if this is a useful way to pull dependencies for your project. General answer is, in some cases it's really nice to use, in some others you might want to use a dependency management tool. But we'll see the various situations when and where this is a useful command to learn to use. And obviously, I have a final topic still related to Git that's a little bit different for the end. So if this is interesting enough, I'd say let's start from Git worktree. So Git worktree, very high-level definition, relatively simple, is something that allows you to manage multiple clones in your working directory of your project. And simple syntax, a very useful feature. Now, you were asking me, why do you have this bird? And the answer is a bird that works on a tree, Git worktree. Yes, fantastic, I know. Thank you. I don't know how I come up with these crazy associations. But to explain you why Git worktree is useful, we have to do like one step back. I want to do a one step back. And that is the general way where if you guys are using branches, I hope you guys are using branches to isolate feature work or bug fix work and be independent and working on that in isolation. This is how it generally looks like. You branch off a certain stable branch, probably master, maybe you call it develop or staging. You branch off and you start and you do some work. Obviously, as you work through your feature branch, people in your team have been working as well, and they've been merging back stuff into master or your stable branch for a little bit. And then you keep working, and maybe the change you're working on is a little bit longer than usual. You don't want to commit unfinished work. You're just like still finishing it up. And somebody comes and says, hey, stop whatever you're doing. We have a bug in production. You have to fix that thing. And if you ran into this issue before, you know that it is a little bit clumsy to juggle multiple branches if you need to swap them out and switch back when there's problems, especially if you have uncommitted work. So I actually have a few bullets about this. So working with multiple branches, Git is very efficient. You can switch to a different branch incredibly fast, but sometimes it's a little bit inconvenient to shift branches as you're working on stuff. So one possible solution that we had over time is, I think what a lot of us do is that just commit this as a work in progress commit. And if you're familiar enough with rebasing or amending, you can just change it later. So you type those commit messages with whip in it, work in progress. If you're a little bit more advanced, you might use the stash. Who here knows about Git stash? Ooh, right, many people know. Cool, I am proud of you guys. So for those that, half of the hands didn't go up. So for those that don't know, the Git stash is actually the way probably, a lot of people save temporarily their uncommitted work on a side. So what the Git stash is a way to, so if you type git stash on a command line, what will happen, Git will take your unstaged, uncommitted changes and of the files that it knows about, not the ones that haven't been added to, to the repository yet, and packs them all in a gzip, puts it on a stack, and it's a stack of patches that you can, it's a stack. The more you add to it, the more they are piled up. And then when you're done, when you're ready to reapply those changes, you just type git stash apply, and that code will be reapplied. So this is a way for saying, when you have that case I showed you before, your boss comes, you have to fix a bug in production, you type git stash, switch to the production branch, fix what you have to do, and when you're done, go back to the original branch, type git stash apply, and you can keep working. But today I'm here to tell you that there's a new way, and it's a cooler way. And it's available since Git 2.5, and it's called Git worktree. So as I mentioned it a couple of times, so that you get used to the idea, Git worktree allows you to create clones with checking out the branch that you want to work on, but you have the full repository at your disposal in a local folder in your working directory. The way you use it is relatively simple. You type git worktree add, where it means I want to create a new clone, and I want to make sure that that new clone is checked out at this new branch that I want to work on, or this existing branch if you already have one. And I'd like to store this new clone into this folder. If you start to use this technique, obviously you will have a few work trees present in your local environment, in your local working directory. So if you want to see all the work trees you're working on, you can type git worktree list. This will list the folder where you have a full clones and the branches that those local full clones are currently pointing to, nothing too extreme. And once you're done, the beauty of the Git worktree is just a full clone that's, let's say, created in a slightly more efficient way than if you would clone it out of band on some other folder. But when you're done, you can just delete it. You can just delete the folder that contained the clone. The only thing you might want to do is tell Git that you removed the worktree. You don't need it anymore, so you need to just say git worktree prune, And what Git will do, it will check if you still have all those clones available, and if not, it will remove the metadata that Git stored. From the high-level presentation, you think, very nice, maybe I can use it, but I think you understand things a bit better if you see it live. So let's do it live, as they say. So demo time. I might switch and unmirror the display. That way I see what I type, otherwise I need to look at the screen. Okay, we'll do this exercise a few times. So can you guys read in the back if I type? Yes, a little bit? Somebody nodding in the back? Yes, okay, I see some nods in the back, okay. So just for the sake of this example, I picked a project I was working on a while ago. It's a workshop I was working on a while ago, and because I rebased all the history, there's only a couple of commits. But let's say I'm starting to work on a long-term branch on this that's going to take a while. And so I want to keep all that work isolated in a branch and actually in a local clone. So let's create a worktree for this. I do git worktree add. Then I specify the branch name. So many people use different formats for branching names. We sometimes specify when it's a feature, we add the prefix feature. In this case, I use demo1, say hello Poland, and then I specify a folder where I want to store this new clone. And what Git will do, it will create a fresh clone of the entire project checked out at that branch. So if I now go inside the hello Poland, folder, you see that I have now checked out into the feature demo1 hello Poland, and I have a full clone, and I'm checked out in that branch. Number of commits is the same. Now let's, for the sake of this example, just do a code change. Yes, if I can type. Readme, there you go. I'm going to change this to Devoxx Poland, and also here. So I just do a very quick readme change. I get status. Yes, I change that. I commit. Say update, date, readme, demo. I created a commit. If I list the commits, this would be like the normal. You see, I now added a new commit. I just have a slightly more beautified version of Cnit that shows actually the branch where the commits are pointing to. Okay, we created a commit. Nothing fantastic about this. But what I want to show you is that if I go up one folder in the parent project, see what happens. The parent project is still at master, and if I list the commits, it doesn't have the new commit. So this shows you that you can actually work in parallel on branches. So maybe you have a long-running branch that it's going to be done in 3 months, but you still need to do some feature work, and you still need to fix production issues on master. This is a really nice way to do it. You just keep a work tree on a branch that you want to work on. So the other thing I wanted to show you is how does this technically happen? So you know that Git tracks everything in a folder called .git. If we look at the .git of this clone, what we find is something interesting. First, it's not a directory. It is just a file. And it's a pointer to where Git is storing the metadata about this clone. Let's check it out. So if I change directory to this thing. So what you'll see, first you need to see where it's stored. It's still stored in the .git folder of the parent project, and it created a worktrees section. And it just contains pointers to the new commits. It will store a log of the objects that you create into this clone. But the object database is the one of the parent project. This allows Git to keep full clones, but do not explode the size of your working directory. It's a very efficient way to manage local clones. And if we go back to the project, just want to show you one extra command. So once you've been adopting this technique for a while, you will want to know how many worktrees do you have. So you can ask it with the list command. So this will show you, okay, you have the master of the project is on master, the local directory, and you have created a full clone that's right now it's pointing to this feature, and it makes it really nice to work in parallel on multiple branches. When we're done, now I created a commit, I didn't push it anywhere. It's just for the sake of this demo. Let's say we're done with that work. I can just remove the folder. So remove the Hello Poland folder. And then I do git worktree prune. And if I do this and try to list the worktrees, see there's no, the one I just created is gone. And the final bit I might want to do is, there's a branch that was created. Those objects are still in my objects database, so the branch pointer is still available. So if you're done with it, you might want to delete it. So we do delete the feature branch, and then we're done. So this is what I wanted to demo. Now I have to juggle the mirroring and a mirroring. There you go, a mirror. And go back, full screen. Okay, so I lost the clicker. There you go. So when is this a great choice? Just to wrap up this topic, and it is, not all of us need to work in parallel on multiple branches. And some of you are lucky. You just pick a branch, work on it. When you're done, you merge it. Maybe some of you are even luckier, just by yourself on a project, you just work on master. But in a slightly bigger development team, it happens often that you need to juggle a couple of branches. So worktree is a really nice, useful addition to your Git toolkit arsenal to do that. Also, there's one other use case for this. If you guys are working on massive legacy projects or big projects that take a long time to build, one technique that some people use is to create a worktree just for running the tests. That way, your IDE doesn't get unresponsive because temporary files are created or some configuration files are changed. You can run your tests in a worktree while you work in the IDE on something else, and everything stays responsive. So dare I say, it might be, if you learn this technique, maybe it will replace the way you do branching day to day. You just, instead of branching off with git checkout -b, you might just do git worktree add, and it's a different way to work. So I encourage you to check it out. That was my section about git worktree. You tell me at the end if you liked it, if you think it's useful. The second thing I want to tell you about is about the magic of fix-up. And it's an incredibly powerful technique once you learn it. And to understand the whole technique and how it works, we need to do a little step back and explain you the reasons for why you might want to adopt this. So, if you work with code, you know it's really nice to work in small chunks and commit as often as you can so that you know everything works, all tests pass, I do a little bit more change, I commit, and everything you commit works, and you're happy. It's a really terrible experience, one that I am very familiar with, and that is you work a little bit too long on things, and then you don't know anymore what broke what. You change too many files, and now it was working a little 5 minutes ago, and now it's not working anymore, and you need to debug your own feature that you're working on. It's terrible. And if you think about it, the only problem with this is that there is quite a tension in software development as you want to keep your, say, code history clean so that you can easily share it with your colleagues. There is always this tension. And there's a tension between I want to save as much as possible because that way I know everything works and I can see the evolution step by step of my code. But at the same time, when I share my commits, I want them to be very clean, atomic, readable so that my team can understand what I did. And not like, oh, temporary, work in progress, I tried this, tried that, oh, fuck, doesn't work. And maybe you have like 20 commits that don't add any meaning. The question is there a way to make both scenarios work and save as much as you like, but at the same time, make sure you can clean things up? Many of you might know what the answer is, but I thought, so is there a way to square the circle? And this is my fantastic say yes. Yes, there is. The way to do it is using a rebase. So I don't know how many of you guys are familiar with interactive rebase. Please raise your hand. Not as many hands as before, say 25, 30% of you. So for those that haven't never done an interactive rebase, so in very general terms, a rebase, automated or not, is a way to replay commits one by one on top of a branch. And the slightly more advanced way of doing a rebase is the one where you specify at each step of your history what to do with each commit. If you want it by itself, if you want to squash it into the previous one, if you want to actually remove that commit, if you want to change the commit message. And this is a very useful technique to rewrite the history of your feature branch before you share it with your colleagues. Some of you are familiar with it, but today I want to show you the next step, something that will make this cleanup easier. It starts with one line that you can memorize or you can look up. It's very simple. You just want to turn on this feature, which is autosquash. So you say, whenever at the rebase, I want autosquash to be turned on. If I just give you time, some people were taking a screenshot, but this deck will be available online, so you don't really need to take a picture of this. So once you've done this, you can, as you work through your features, you can keep saving as much as you can, but now you gain a superpower. And the superpower is a way to annotate, basically, the commits with special tags. And the special tags are --fixup and --squash and --reward. There's actually 7 tags or seven flags you can use as you go on committing. And what this does is that it preempts those commits. It actually annotates those commits so that when you're going to do a full cleanup later, Git will know what to do with that commit already. So imagine that you're working through a feature branch and you realize you had missed updating a piece of documentation. Like we saw previous talk, talking a lot about making proper and useful documentation. And you realize, I added that change, but I didn't update documentation. So you know exactly to which commit you would need to add those changes. So you could use something like commit fixup. So that will give you even a better trick than to actually go and find the commit ID of that change. If you guys use any sort of project tracking tool, issue tracking tool, or you have an issue ID together with your code, and you know that that specific feature you were working on had a certain identifier, like project 123, you can say, this code change I just made is a fix for that. And Git will create a commit for you, annotating it already to be weaved into that commit for you. So you will get a rebase table of operations for the interactive rebase, pre-filled already for you. Now, because I understand that this is a little bit abstract, you need to see something real, and we're going to do it together. So again, we're going to do it live. So as I swap, this is always a bit annoying, swapping between mirroring and unmirroring. OK, I have another project checked out for you. So let me show you how the branches look like. So this is how the command, how you would type it if you don't have aliases. Forgive me, I have a short alias that annotates it with a few more branches. So you do git ls. It just shows where the branches are. So I've been working on a small contribution to Git related to subtree, which we'll talk about it in a bit. And upstream, so where the Git contributors send main repository is at, is stop at master. And I have a branch which has 3 commits. And I realized that actually in my first commit, which has a key, we're storing some information in an issue tracker about what I'm doing, I realized that there I didn't do good justice. I forgot to modify something into README. So it's a very simplified example. So before I share this work with my colleagues, or before I mail the patches to the Git mailing list, I want to make sure I amend that commit. Because I've turned on autosquash, I can do it this way, just so that I don't mistype things. So I do, let's do first a change. So I change this to Devoxx. Oh, no, wait. You guys didn't stop me. We want to work in the new way. We want to create a worktree first. So let's do it. Worktree -b. It's a feature. It's actually a bug fix. So bug fix. bug fix, demo 1, hello Poland. Let's do it quick. Hello Poland, and then a folder, fix bug. All right, I didn't add the command. See, we're doing it live. Okay, so I created a new work tree in a folder called fix bug. So now I know I'm actually working on that. Whatever is happening anywhere else, I am safe. If I check out the previous 5 commits, they're the same as I showed you. And now let's resume where we would do what we were saying. I forgot to update the README. Okay, let me update the README very quickly. I update the README if it comes out. Yes. Devoxx test. And okay, now commit it. Git commit update. README. Okay, so I just did something you guys didn't notice, but power of live demo. I didn't use fixup, so Git doesn't know it needs to add those changes to the right commit. So I'm just gonna undo it. I'm just gonna do git reset hard head. So we're going back 1 commit. I don't know if you know this technique. So we do this. I have basically deleted 1 commit. Okay, nothing happened. Let's redo the change. And Devoxx. Okay, I did a commit change to the documentation, and now we get to the useful new command that you can use, which is git commit -a, because I want also the unstaged changes, and I say fixup, and then I say, look, it's the commit that was actually had the keyword 3.1, and so Git will take my change and add it, and then create a commit, adding it for so that it's marked as if that commit will be fixed. So it looks like this. So basically, Git created a commit where it added a fixup tag to it, but also it recorded to which commit it should be fixed. So now if I do a cleanup before sharing my work, doing a rebase, so I do git rebase interactive, and I want to rebase until the upstream master commit. This will open the famous table of operations that the guys of you that have already been doing rebases know, only that Git has already placed the fixing commit in the right place, and it will correctly weave that in at the 3.1 commit. So if I just save this, Git will replay all these commits. I will look at the commits. As you can see, there is that fixup commit is gone. And if I do show the list of files that I changed in these files, you'll see that now the 3.1 commit has that change that I made. So you realize you need to amend or check or change something in a long list of commits, you can use this git commit fixup right away. The difference between using, so this is what I wanted to show you. And the other thing is, as we go back to mirroring displays, the other thing that I showed you here is you don't need to use fixup. Fixup is for just change this commit, the commit message is fine. Sometimes you have to amend commits but add some explanation to the commit message. For those changes, you might want to use squash. Squash will actually retain all the commit messages of the commits that you're merging together. All right. This was a brief say, passage through these fantastic techniques of autosquash plus these flags. So I encourage you to explore them and see if they can enhance your daily work as you work through your branches. Third topic today is project dependencies with Git. And then this is your face. As I bring up the topic, you go, tell me more about it. So it's a big topic, and the broader answer is you shouldn't use Git to track project dependencies. We'll get to that later. But before I spoil this fantastic new tool, I want to tell you a little bit Git subtree. So Git subtree has actually been in Git for quite a while already. And it's a very cool tool that can allows you to pull any source in any Git repository extraneous from your parent repository, pull that dependency and store it as a commit in a folder that you decide. It's also a tool that allows you to take a folder in your project, extract it out, and store it as a separate repository. So it's a quite powerful tool all in itself. Now, why I'm bringing it up as a nice tool to handle project dependencies? There's a few situations where Git subtree might be the right choice. Not all cases. Don't quote me that I said you should use Git subtree. But there are some specific scenarios where it's really nice. The first reason why Git subtree is very cool, and in some ways cooler than submodules, is that if you have one person that manages dependencies for your project, all the other team members don't need to learn any new syntax, don't need to learn about Git subtrees, because Git subtrees stores all the information about the external project in single, regular, normal commits. Every time you update a dependency, you will have one commit plus one merge commit inside your history. And so that's the third reason why it's really nice. You will see really easily in your parent process project commit history whenever you updated a dependency. So your team doesn't need to know how to use it, only the people updating the dependencies. It stores the updates to your dependencies in regular commits, and it's very easy to see when this happens. Let me show you how it works. So imagine you realize you need to depend on an external dependency for your project, and you want to use Git subtrees. How do you pull an external repo in your parent repo? You do git subtree add. You specify in which folder you want to inject that external project. You specify the repository where the external project resides. And then you want to specify which branch or which version or which tag you want to use. I had put master there, but obviously if your dependencies you want to rely on, probably you want to specify which tag, which version you want to use. The squash part at the end tells Git subtree, as it pulls the commits from the external project, to squash all those commits into a single one. This way you do not clutter the entire history of your project. The way that Git subtree allows all this magic is by annotating the merge commits that it creates, or the commits that it creates as it squashes everything together with a couple of extra metadata items, specifically the SHA-1 of the version it is pulling from the external repo. That way it can use that one the next time that it goes and fetches updates. So it stores unique identifier of the commit of the project you're importing and where it did import it. So it's in the Git subtree directory parameter, it stores where. So Git subtree actually creates two commits, a commit with the code and a commit that is a merge commit, so that you can realize that some integration happened at that specific commit. When you want to update a subtree, so if after a while you realize you need to update a dependency, you use a command, git subtree pull, you specify where you wanted this dependency to be injected, steal the repo, and in this case, you might want to, obviously, if it's a new version, you want to update the version that you're pulling. In this case, I wrote there 1.5. Obviously, it will depend on the project you're importing. And also add squash so that all those updates are added as a single commit. So, yes, already mentioned how under the hood that looks like. Because Git subtree at this moment does not resolve these unique identifiers that it pulls from the external dependencies, there's a command that you can use to actually go and resolve them, and it's called ls-remote. So if you see a commit where you updated the dependency and you didn't change the commit message to say, I updated dependency to version X, you can find it out by just typing git ls-remote and grabbing for the unique identifier that you find in the commits. You shouldn't bother too much about this. It's just like something that comes up if you wanna learn what's happening by looking at the history of a project. Now, those commands are a little bit long, and you know what you do when a Git command is a little bit long? You create an alias that makes it shorter. So I created a couple of aliases to make the process a little bit easier. You don't have to memorize them. I created an alias that points to some aliases there, bit.do/git-aliases. And if you add those aliases to your Git configuration, the way you add the subtree becomes git subtree add the path to the remote repo and the folder where you want to add it, which it becomes much more, user-friendly, and I can remember what's the syntax of this. Now, obviously, this is nice. It seems very clean. It stores all the dependencies as single commits. It's a single command. There's a lot of pros. There's also some cons of using git subtree. When not to use git subtree? If you have a full-fledged big project that has hundreds of dependencies or dozens of dependencies, maybe git subtree is not for you because you need to pull all those dependencies every time you want to update them. And if also it's not the best if every day you need to update 5 dependencies and you will have those 5 commits updating those in the parent project, your parent project, that might be very optimal, very nice to look at, and it's a little bit of a pain. And third, if you give you as a benefit, none of in your team needs to learn it apart from the person updating the dependencies. But if everyone updates dependencies all the time, you lose that benefit. Everybody needs to know how to use git subtree. So it has quite a few nice features, but it's not good for all software projects. And the broader discussion about this is whenever somebody asks me, so how do I manage project dependencies with Git? And my answer is always, use a dependency tool that's good for the technology stack that you used. That's a broader answer. I actually wrote about this a while ago. And for any technology stack, in Java we have Maven, Gradle. For JavaScript we have for Node we have NPM. For any technology stack, for Ruby we have Gems, Bundler. For any technology stack there is a dependency manager, and that might be a saner way to handle project dependencies. But for small projects that require some external dependency, git subtree is really nice. Git subtree is actually amazing for another use case. And if you've tried to do this before, you know how hard it can be. And you can use git subtree to extract a folder in your project and create a new repo from it, maintaining the history of it and preserving all the history of those files. And this is my metaphor for it, the parting of the waters. So the way it works is like this. Imagine that you have a big project, you realize a part of your project can actually be abstracted out, extracted so that you can share it with some other team or maybe open source it. The way you do it with the git subtree is like this. You specify git subtree split. You specify in which folder you would like to extract out as a separate project, and you specify in which branch you'd like this extraction to be stored into. So git subtree will store all the history of the files changed by each commit, preserving the commits of that specific folder, and it will store the result in that branch. So if you did that for a specific branch, the next steps would be, now you can remove that folder from your parent project. You can initialize a new repository where you will pull that specific branch where git subtree has stored that dependency. And once you're done, you're done. You can just add the remote for this new repository and push it somewhere else. So if you guys have ever tried to use filter branch to do this sort of operation, you know how much easier it is. This set of steps. Git filter branch has hundreds of knobs, and it's relatively more complicated to use. Okay, these were the 3 techniques I wanted to show you today, 3 new things I wanted to show you today. I have one last one, and that is still related to Git. As I was looking at an image pipeline, apparently pipelines can be quite strong And this came up. So, we were talking about fast feedback, you know, running tests every time you commit something, making sure everything works. What I have for you today, just a couple of weeks ago, we have announced Bitbucket Pipelines, which is completely embedded. I don't know, who here uses Bitbucket or knows about Bitbucket? All right, 25%, okay. It's a Git repository. It's free, for unlimited, free for private repositories. And right now, we have announced that we have support for builds, continuous integration. So you can, by defining a simple descriptor, you can build your project every time you push changes into your Git repository. You turn it on by just clicking a button where you say Enable Bitbucket Pipelines. And you define a descriptor, you define a Docker image where you can run and build the tests of your application. It's in YAML format. It already has support, you know, predefined configurations for many different technology stacks. And every commit you push to a Bitbucket repository and turn on Bitbucket Pipelines, you'll be able to see if, you know, it building your source code, running the tests, and tell you if they're successful or not. We also have already quite a few integrations. So from pushing the code on Bitbucket, you can actually push information packages onto quite a few providers. It's in beta now. And if you want to sign up, if you already have a Bitbucket account, you want to sign up, I have created a short URL for you to try, bit.do/pipelines. So to wrap things up, what we covered today, a cool technique if you are one of those persons that need to work on multiple branches at the same time, give Git worktree an attempt. If you like to save commits as much as possible, turn on autosquash and experiment with the fix-up, squash, reward features that you can attach to your commits so that your rebases become much easier. And if you want to pull some dependencies for, you know, ad hoc solutions or for smaller projects, try out Git subtree. And I'm sure you will find it you know, a powerful addition to your arsenal. And with this, I want to say thank you very much for listening and laughing at my stupid jokes. Thank you. Thank you.